So this question, we have a sequence. A sub n is n plus 2 over n squared. We want to find values for a equals 1, 2, 3, 4, and 5. So let's start when n equals 1. So wherever we see an n, we're going to replace it with a 1. So n is 1, a sub 1 equals 1 plus 2 over 1 squared, 3 over 1, which is 3. So we get a sub 1 is 3. Next, we go to n equals 2. So replace that n with 2. A sub 2 is that n with 2. 2 plus 2 over 2 squared. 4 over 4, which is 1. So a sub 2 is 1. Now let's go to n equals 3. A sub 3 equals 3 plus 2 over 3 squared. 3 plus 2 is 5. 3 squared is 9. So a sub 3 is 5/9. Let's go to n equals 4. So plugging the 4 in for n, a sub 4 equals 4 plus 2 over 4 squared, 6 over 16, which is 3/8. So a sub 4 is 3/8. And finally, let's go to n equals 5. And I have a sub 5 equals 5 plus 2 over 5 squared, which is 7 over 25. So a sub 5 is 7 over 25. Now we can check this on the calculator. Let me show you a couple ways we can do that. So I would like to make sure we are in sequence mode. So the mode button here is, you'll notice currently the mode is on function. So if the mode is on function, when I hit y equals, it enables me to go to the editor where I can put in functions of x. But instead, I'm going to go ahead and change the mode to sequence. So come down, change the mode to sequence. So now when I go to y equals, I can actually put in a sequence. So our example was n plus 2 over n. This button now becomes n if I'm in sequence mode. N plus 2 divided by n. And I can go to the table, second table set, starting at 1. Change in table is 1. Fine. It should start 3, 1, 5/9. Let's see if it does. N plus 2, did I do that correctly? N plus 2 over n squared, let's fix that. N plus 2 over n squared. And let's try it again, second table. 3, 1, 5/9. So that looks good, 3/8, 7/25. Indeed. But what I think is a little more useful, frankly, is to go to second stat and go to ops, and you'll notice sequence here. Enter. Our expression is n plus 2 over n squared. Again, here is our n as long as we are in sequence mode. N plus 2 divided by n squared. My variable is n. I'm starting at 1, ending at 5. And we're stepping 1 each time. So all this does is this pastes the information into the relevant line of code, and we get it there. So you could go directly to SEQ and plug that in. If you were so inclined, we'll go ahead and change those two fractions to see if they match and see what we have. 3, 1, 5/9, 3/8, 7/25. What did I say? 3, 1, 5/9, 3/8, 7/25. So that looks good. Now, what else do we need to do? We are trying to do the sum as k goes from 1 to 50 of a sub k. So let's take a look at that. Sum as k goes from 1 to 50 of a sub k. But what is that? right? Sum as k goes from 1 to 50 of a sub k, or maybe better yet, the sum as n goes from 1 to 50, using our same notation, and this is better notation for our graphing calculator, which will be the sum as n goes from 1 to 50 of n plus 2 over n squared. You want to be comfortable going back and forth between k's and n's, depending on textbooks, depending on approaches. Those are the two letters most often used. So let's go back to the graphing calculator. And this time we're going to go to the math button to 0 all the way down, scroll it all the way down to 0, and you'll notice summation notation. Looks like it went a little bit too far. 0 is your summation. Hit enter, and you'll notice this version of the calculator is very helpful. I want n to go from 1 to 50, so my variable is n. I'm in summation mode, sequence mode, so I should be okay. N goes from 1 to 50. And then what do I need? Then I need n plus 2 over n squared, so parentheses n plus 2. Parentheses divided by n squared. And we'll see what the calculator gives us. 7.749. And we were supposed to round how many places? Does it say 3 decimal places? So indeed, our 7.749 looks like what we are asking for. So the calculator is very helpful to evaluate large sums like this.